video, we're going to see the solution to this geometry problem using three variables. We have a triangle. It says the largest angle in the triangle is 52 degrees more than the smallest. The sum of the measures of the two smaller angles is 10 degrees more than the measure of the largest. Part A, let x, y, and z be the measures of the three angles from largest to smallest. So let's go ahead and do that. So I'm going to let x be the largest, y be the middle angle, and z be the measure of the smallest angle. And all three of these are the measure of. Okay. Then it asks me to write a system of three linear equations. So to do that, I'm going to make a picture. I'm going to let x be the measure of the largest, y be the measure of the one middle, and z be the smallest. And then I'm going to come up with three equations. The first equation I'm going to use from the first sentence. The largest angle, which one is the largest? Oh, it's x. So x is equal to, is 52 more than, so 52 more than means plus the smallest. Oh, and the smallest is z. So the largest is 52 more than the smallest. Then the next line is going to be for my second equation. The sum of the two smaller. What would that be? Oh, that would be y and z. The sum of the two smaller is 10 degrees more, so is means equals 10 degrees more, that means plus the largest, and the largest is x. That's my second equation. And finally, my third equation comes from a geometry fact that they're hoping that you know, that three angles, if you look at the notes, they actually do have it in there, that three angles always add up to 180. I think I will add that to the test question in case somebody doesn't know that. Angle, the measure of the three angles adds up to 180 degrees. That's where the third equation comes from. So labeling these three equations, we need to use elimination to solve them. Before we do elimination, it's best if you put these in order. So I'm going to go ahead and do that with the first equation. So I'm going to take and to put this in order, I'm going to subtract z and put it on the other side so that the way they can all be aligned up. So I'm going to get x. I don't have a y, so I'm going to put a space, minus z equals 52. On the second equation, I'm going to get that x and put it on the other side to line that up. The x's first, negative x, then the y's, then the z's, equals 10. So all I did is subtracted x, negative x plus y plus z equals 10. The last equation, I'm just going to leave alone. So those are my three equations lined up. Now I notice, if I want to use elimination, that if I look at the first two, it actually is going to be very easy, because if I just add those together, both the x's and the z's get eliminated. So that's what I'm going to do next. I'm going to take 1 and 2, and I'm going to add them up. So when I add them up, what do I get is, again, the x's and z's go away, so you get y is equal to 62. That gives me the y. Because of this scenario, we don't have to do much work. It's not like solving a system of three equations, three unknowns, where nothing goes away. Usually you would have to do a little bit more work. You would eliminate just one variable at a time. You'd have to do that a couple of times until you get down to a 2 by 2, and then do elimination again. But this time we're lucky, so we could just do back substitution and plug in a y is 62 into both of these, and then you can add those together. The other way you can go is you could decide to eliminate the y's in the second or third. So that would be the second way to go. Maybe we should try that. Let's choose to eliminate one of the other variables. Like, let's eliminate x from two of these equations. You have to pick a different order. So let's just pick 2 and 3 and eliminate x. If we were going for eliminating x in the first two anyway, and you wanted to eliminate x again in the second two, so let's eliminate x. You could just add these together, and again I just picked a different pair than I did here, and I get a 2y plus 2z, the x's go away, equals 190. So if only one variable, say x, went away here, then you can see you could easily solve this. In this case, you don't have to do much because you already know that y is 62, so you could just plug in a 62 in for this y and solve for z. So what would that be? Well, 2 times 62 is 124. I hope that's right. I think that's good. Plus 2z equals 190. So then we're going to subtract 124 from both sides. So what would that be? Let's see, that would be a 6, 8. So I think that would be a 6, 66. Hopefully that's right. And it looks good to me. So z turns out to be, let's scroll down a little bit more, dividing by 2, 33. Finally, we are going to find x. So I can use any equation that has an x in it, and they all three do. So I'm just going to go for the last. That looks nice and easy. So let's do it over here. X plus y plus z equals 180 is the third equation. And if I plug in a y is 62 and an x is 33, z is 33, I can find x. So adding 62 plus 33 is 95, and subtracting 95 from both sides, we get x is 85. So that tells us, scrolling back up, that the smallest angle, or the three angles, is 85 degrees, is the largest, 33 degrees, 62 degrees is the y, is the middle, and then 33 degrees is the smallest, the x, y, and z. Now if you scroll back up and do part C and check your answer, let's see. Well, we do know that they all add up to 180 degrees. You can check that on your own. I used that there to find that, so I know that that is true. I do know that x is the largest, y is the middle, and z is the smallest, so that's good. The largest, which is 85, is 52 degrees more, so if I add 52 degrees to this, I do get 85. And the sum of the two smaller ones, that's 95, is 10 degrees more than the largest angle. That does work. So that is your three answers.